distributed cache. What is a distributed cache? Distributed cache is a memory, a cache memory, where we can keep a set of file or a file which will be accessed by multiple mappers at the time of execution. What is that? What does it mean? Let's say you have a two different data sets. Two different data sets. Let me bring to an example. Like you have employee data as well as you have department data. You have employee data as well as department data. So compared to department data, employees will be a bigger data set. Hardly your department will be 10 departments or 20 departments, but employees will be in hundreds of employees, right? Employees will be in a hundreds of employees, correct? Right? So now you want to join something like what are the employees are belong to which department. Department wise you want to bring all the employees and you want to start doing some aggregations. Department wise you want to bring all the employees and you want to do some aggregation, right? So how to do that? I have one department data set. I have one employee data set, right? So now employee data set will be bigger data set and department data set is a small data set. Now I want to do some aggregations based on the department and what are the employees are belong to department. We have to do it. Any idea, guys? How can we do this? How can we do this? Any idea? Madhu?
What is the question, Viru?
Okay, very good. The question is, I have a bigger data set, one bigger employee data set. I have one employee data set. I have department data set, which is a small data set. Now, now department wise, I want to bring all the employees. Department wise, I want to bring the all the employees. Let's say this employee data has ID, name, and sal department ID. Here department ID, department name of the department. I have a here two columns in the department table. I have a four columns in a employee data set. Okay. Now department wise, I want the all the employees. No, so my data set looks like my data should look like DEPT ID, name of the DEPT, department name, employee ID, let's say EID. Okay, employee ID, name, salary. I want print these details. Now I want my table should be joined like this. My table should be joined like this. So how can we achieve this in Mapreduce? So if it is the SQL, we can do a joins. Correct? Based on the department ID, we can do a joins. Then based on that, we can get the details. So in a Mapreduce, how can we do this? Madhu? or Raghu, Srikanth, or Anila? Mapreduce joins. Okay. I mean, I want to understand what you are thinking, what your thought process about it. How will you do? How will you give the input to your Mapreduce? How will you give the input to a Mapreduce? So will you give two input files as a input to your Mapreduce, or you will give only one file as input, or you will keep both the files in a directory and you will give the directory as input to your mapper? How will you give this? Okay, so let me reveal the suspense. Let me break the suspense. Very simple, very simple. What we need to do, we need to take both the files, both the data sets, and we know that the department dataset is always small than employee dataset. So now this department data set should be available for all the mappers. One thing try to understand guys here. If it is employee dataset, if I'm giving both our input to a MapReduce framework, both will be splitted into pieces and one mapper will be processing one piece. There may be a chances let's say your department has been broken into two pieces. So when the mapper is accessing, which piece will go to which mapper? Which piece will go to which mapper? This means your department data should be available as it is. It should not split. It should not split. The whole department data should be available. The whole department data should be available. It should not be like it should not be like partitioned. It's not like partition. It should not be like processing by other mappers. Other the ma the mapper, what are the mappers are processing this employee data? What are the mappers are processing this employee data? Those mappers should be access. Those mappers should be access complete department. Then only can the join is possible. Let's say I have four mappers are launched. The four mappers should access complete data set or complete department, right? Yes or no? Are you guys able to follow? Madhu, Nagi, Raghu, Srikanth, Anila, or you guys are lost? Please, please, this is one of the important topic in the MapReduce. I want you guys to understand very clearly and detailedly. Madhu,
Yes, Vira, yeah, we'll put that in the cache and we will, in the mapper, we'll try to get that from the cache to join and get the other details from the
right?
data.
Why we need to put into cache? Because if you keep it as normal as a normal data set, this also will break into pieces. Yes or no? This also break into multiple blocks, and this also will go for the processing for the multiple mappers. And if it is broken into pieces, mapper one, and let's say this also broken into multiple input splits, so there may be a chance one mapper will get only one piece or the rest of the piece may not get. Are you guys able to follow what I'm trying to say? Anila, Srikanth, Raghu, Nagi? Guys, I'm not able to hear you guys. Very simple. Let me put in another way. Let me put in another way. So now I'm going to explain you another way. Now I have employee dataset. I have a department dataset. My department dataset should join with my employees. My department data should join with the employee. So if I case one, case one. So both. Let's assume that you don't have any cache memory. Let's assume that you don't have any cache memory. So then how you will solve this problem? when you keep when you give both as input format, when you give both as input to your MapReduce framework, what will happen? Input splits will be calculated for the both the files. Input splits will be calculated for the both the files. So both the files will be processed separately. Both the files will be processed separately because we don't have a specific mapper. We are not going with a multi-input format. We are not going with a multi-input format. You may say that, sir, I'll go this with one multi-input format. I'll go with this one other multi-input format. Okay, and if you guys understand the multi-input format, I have already explained that in the last classes. If anyone of missed that, please go through the videos, please have get an understanding of it. So you may say that, so I will write a different logic for this mapper, I will write different logic for this mapper, and I will process them at the reduce side. I will join. Absolutely correct, you can do that, but you can do that but you have to do a join at the reducer level. You have to process them with a different mapper logics. You have to process them with a different logic. That it can be possible, you can do it. I'm not telling you you cannot do that, you can do it. So you will write a department mapper class and you will write employee mapper class. You will process it, and this is the key. You will take this as the key at the reducer level. At the reducer level, based on the key, you will join. Yes, that can be done. That can be done. Okay. Next, case 2. One is the at processing with the different mappers, different map logic, multi-input format. Let me put in the multi-input format. Very simple, guys. Multi-input format means one file will be processed by with another mapper, another file will be processed with other mapper logic. Two different mapper logics will be there. So like let's keep it here. Employee mapper, department mapper, department mapper. So two mappers will be there, and this mapper will be processed by department data. This will process by employee data. It can be any number of mappers. Any number of mappers can launch for this. Any number of mappers can launch for this. What you will do, you will take the data, both of them you can join at the reducer level. That can be possible. Case 1, that is. Right? Case 2, which is a failure case. Which is a failure case is not possible. Let's say you have only one mapper. You have only one mapper. If you have only one mapper logic, this has to process with that mapper logic and same mapper logic has to process. You cannot join. That's not possible. That's a failure. The other possibility is distributed cache. Distributed cache. What is a distributed cache? The name itself is saying the distributing the data. Distributing the data. Okay, there will be a cache memory. There will be a cache memory. You will keep your small file into that cache. Keep the small file into cache. Here, what is the small file? Here your data set, department data set is the small cache. Keep the data into small cache memory. Distributed cache. Distributed cache, and you write your mapper logic. Employee mapper. In this employee mapper, each record you're processing, you go ahead and map with this. You go ahead and check whether this department ID is available here or not, whether this department ID is available or not, whether this department is available or not, whether this department is available or not. You can take multiple input splits, multiple mappers can launch, no problem at all. Each mapper will go and talk to distributed cache and will get the copy of the distributed data, and it will start lookup. It will start lookup. It will start lookup. That is a distributed cache. Do you guys understand? I hope now it is little clear. Madhu, Nagi, Srikant, Anila.
Yes, sir.
Anila, I'm not seeing your response from you. So if you're not clear, please let me know. I'll put in different way to make you understand. Raghu. So very simple. We need to join our data set. that data set should available for all the mappers. Very simple. The whole data should be available, not the parts of the data. If you go with the normal way without a distributed cache, what will happen? Your department data will be splitted into multiple mappers, and some mappers may get the some piece. Some different mappers may get the different pieces. So what will happen? The joining will be wrong. The joining will go in the wrong. So the mapper should get the whole department data. Whole department data. Each mapper, your employee data may be very big file. It can be processing with the multiple mappers. Let's say in this case, mapper 1, mapper 2, mapper 3, or mapper 4. Four mappers are processing. In this case, mapper 1, 2, 3, 4. All four should have a complete data. Complete data. Then only they can look up easily. If they have only piece of the data, this piece here, this piece here, this piece here, so this mapper 4 cannot get the piece of from here. That will go is wrong, right? So that's why your employee mappers, how many mappers are launching for your employee data, those mappers should have whole data of department for easy lookup. Okay, for easy lookup. How we will do that?
Ravi,
Yeah.
one doubt.
Hmm.
See, you are telling it is stored, distributed cache means it is stored in memory, right?
Yes, and some central location.
Yes, that means it is stored in data node, if my understanding is correct.
It is storing in the RAM.
In the RAM.
Yes. Now you have a
Okay.
cluster. You have a cluster, right? So cluster means you have multiple nodes. So while you are when you look at from the outside, your cluster size is, let's say, 4 nodes are there. Each node is 1 GB is a hard disk. Sorry, 1 TB is a hard disk, and RAM is, let's assume that 100 GB, 100 GB, 100 GB. So now your cluster size is 400 GB RAM, 4 TB hard disk. Clear, Anila? Anila?
Yes, Ravi.
Now this distributed cache is something like a RAM memory. Okay. So now that is the reason the data will not be splitted. The data will not be broken into pieces. Okay. Okay. For the processing this data, department data will be bring into a RAM. This process data will be bring into a RAM. What I'm trying to say, initially this data you can keep it in a HDFS. It doesn't mean that it should not be in HDFS. Okay. So when you are giving input to your map, when you are giving input to your mapper, the data should be in HDFS only. No, initially. But what you will do when you are running your Mapreduce framework, this department data will be bring into a RAM memory. For that there is a different API. I'll tell you that. Okay, I'll show you the code so then you can easily understand. Now you guys understand, you have something called a small memory which is called distributed cache, and you have something called normal employee data to process. Everyone clear till this point? Raghu, I'm not able to hear you. I think you're talking something. Okay, so look at let me start because I have stopped this. Now there in Hadoop, in the Mapreduce, there is something called distributed cache API. What distributed cache API will do? Distributed cache API has a set of methods. What those methods will do, those methods will help you to keep a file into distributed cache, and those methods will help you to get the data from the cache. You can using those methods you can keep into cache. Using those methods you can get the data from the cache. Both can be done. How? Let's see a code. This is something called distributed cache dot add local path. There is something called add local path or add cache path. So add cache files. You have a multiple methods are there. You need to pass a second data set as a parameter to that API. Then what it will do, it will add into cache memory. Let's say the department is our small data set. Now your department data has to give as an input to that method. Then what that method will do, that method will keep your data into distributed cache, and your employee data will be as normal as your input to your Mapreduce framework. Let me show you that so you'll get a clear idea. If I show the code, then this distributed cache memory data will be available for each and every mapper. This is very much important, guys. This distributed cache data will be available for each and every mapper. Okay, then each and every mapper, whenever it is processing a single record, let's say each employee record it is processing, whenever it is processing each and every record, what it will do, it will look up with that employee ID. I mean, so that has a department ID, no? For each record will have a department ID, right? As per our data set. Each record, whenever it is processing each record, that each record will look up into cache memory. In the cache memory, to look up and looks for the table saying that whether this data set is available or not. This data set available or not. This record is available or not. Each and every record will look up into distributed cache. Okay, how it will be look up? Question 2. How it will be look up? Ravi, whether irrespective it's a memory, it's a RAM memory, it is a flat file. Department is a flat file. How my file will look up into this? This is a flat file and you don't return any logic there, and you are processing your data using a mapper. I know it is a Java logic. You can take the first record and look up it, but how can it is look up into a file? For that, what we need to do, whatever the distributed cache data you have kept there, whatever the distributed cache data you have kept here, you need to prepare a collection. You need to prepare a Java object. From this data, we need to prepare a Java object. That can be a map, that can be a set, that can be a list. Whatever your convenient way, you have to prepare a Java object. So this department file will prepare a hash map or hash table, whatever the thing you feel comfortable. Then each and every employee record will go and look into the map whether this record is available or not, whether this ID is available or not, whether this ID is available or not, whether this ID is available or not. So it is a hash map or tree map, whatever the map, it is easy to look up. It is easy to look up. Are you guys clear? I hope everyone is clear. So very simple thing. Now let me keep it in a very high level. Now this data will be processed by a mapper, and this data will prepare a hash map, central hash map. You can assume that central hash map. It's not actually central hash map. I'll tell you how it will works. And we'll prepare a hash map. Every time you process this record, it will go and look up into that hash map. Okay, your department data will go into a Java object. Your employee data will go into with a different mappers. If a different mappers. Let's say I have here four records. I have here four records. 1, 2, 3, 4. Here also I have a D1, D2, D3, D4. Now what will happen? Let's say it is processing by two mappers. Let's say it is processing by two mappers. So when they are processing by two mappers, this is mapper 1, this is mapper 2. Mapper 1 has a department D1. So here I have a D1, D2, D3, D4. Let's assume that. It is a IT, it is a admin, HR. There is something called let's you take anything, support or something, okay, or any other team or housekeeping, whatever it is. Okay, now this mapper 1 should have all the 4 departments to look up, and mapper 2 also should have whole department to look up, right? So how we'll prepare that kind of thing? So we will prepare them, using distributed cache. Look at guys here. I think memory is low because I'm I have opened so many Chrome browsers. I have opened so many things. Please bear with me for some time. Uh, what happened? I don't need the outline. I want a window perspective. Mm. Because of the less memory, it is behaving like this, guys. So I'll make it free some memory. Let's look at here the distributed cache demo. Let's look at a distributed cache demo. Okay, let me explain here. Okay, so this code was written using Hadoop 1 framework, Hadoop 1, Mapreduce 1, and now we are using Hadoop 2, Mapreduce 2, right? So that's why it is deprecated. It doesn't mean that it does not work. It is there. So we can, I mean, the respective methods are available, but I didn't get a time to look up and change them. Not to worry about that. That way is the same way. Okay. So you have to pass the 2 files, file 1 and file 2, 3 files, actually 3 input path now. The first path is your normal input, second path is your distributed cache, third path is your output. For a Hadoop job, now for a Hadoop job, you have to pass three parameters. For a Hadoop job, you need to pass three arguments. The first arg1 or arg0, whatever you call, is nothing but your input to mapper. Arg2, what are the way you take, guys, what are the way you give? You can give any order, you can give any order, so output path, output path, arg3 or arg3, in this case arg2, it comes cache file. I mean, it's also input to a mapper only, but it's a cache file. Okay, but in this example I have taken very first one is a cache file, second one is input format, third one is output format. The first one is a cache file, second one is, so in this example I have taken, sorry, in below example arg of 0 is cache file, arg1 is input, arg2 is output. Okay, in this below example I have taken like this. Okay, so let's try to understand, guys. So when you give three inputs in your Hadoop jar path, and driver class. This is the way we'll execute the no this is the way we'll execute your jobs, if you guys remember. Fully qualified driver class. Let me put it in a brackets. You guys might be uh, forgot. Let me put in this way. Okay, then input, then output, then cache file. This is the way, right? Hadoop jar path, and fully qualified driver class name, input file, output file, or cache file. Correct? This is the only will give the inputs to your mapper. Yes or no? This is the only will give. So now here, what I'm doing in this example, if you see here, in this example, I'm taking the arg0. In this example, my arg0 is nothing but our cache file. That cache file I'm adding into distributed cache. I'm adding into distributed cache. How am I adding distributed cache dot add cache file and new path of this and job configuration. And job also you need to tell for which job it is. You are giving a cache file for whom it is. You need to specify that with the configurations. And your mapper class and your and the rest of things are same, and your input path, your output path, your input path, output path. So what Ravi, you have given something different here. It's nothing, guys. I'm returning some different method here to remove existing output path. So if you look at here, you'll easily understand this simple method. What I'm doing here, I'm taking that if the path exists, delete the path, nothing else. We have seen in our first example how to delete the if a folder is already exist, because your Mapreduce will not create output directory if you already exist. If output directory is already exist, your mapper job will fail, saying that output directory is already exist, I cannot create. Okay, so that's why I have written remaining everything is as similar as same. Then there is a small change in your mapper class. Look at, guys, here in the mapper class, this is very much important. So in the mapper class, in the setup method, why we do setup method? Because setup method is the one who will execute only once in the life of mapper, each mapper. The setup method, I'll bring all cache files. I'll bring all the cache files. Okay, I'll bring the cache files. How will bring the cache files? Look at here. This is I have declared a path because I need a path. So that's why I have declared a path. So I'll bring all cache files here. I'll bring all cache files here in the setup method. Look at here. Cache files equal to distributed cache dot get local file cache local cache files. Get the local cache file. What it will do? It will bring your department file. It will bring your department file path, not actually a file. It will bring the path to this. Okay, now path equal to null, it means no cache file available. Okay, if path is not null, okay, then we will read using buffer reader. How we will read the file? It's a file, right? It is a file. So we need to prepare from the file. We need to prepare some Java collection object. How will you prepare? Like this. We are reading line by line. We are putting into a mapper. Look at, guys, here. We'll read the line by line. I'm putting into a mapper. What is my lookup? Lookup is nothing but my hash table. You can take a hash table, or you can take a hash map, or if you don't want the duplicates, you can take the tree map also. Cache files location is RAM location, not disk location. Yes, cache file is the see, initially it will be in hard disk only. That's what I'm trying to say. So when you give this path, when you give this path, this path is HDFS only. This path will be HDFS only. After doing this add cache, after doing a line number 49 here in my program, it will bring into it will bring into RAM memory. It will bring into RAM memory. Initially, it will be in HDFS only. Don't get confused that. It will be HDFS only. This is also HDFS only. This is also HDFS output only. If you are running in a Mapreduce mode, if your job is running in a Mapreduce mode, not the local mode. Local mode means you are running through Eclipse. You are not running through Eclipse. Understand, Anila? Anila? Okay. Okay. So you'll read the file. You read the file. Prepare a map or a hash map out of the, because I'm preparing a map because it's easy. Key value pair. It's easy. My key is the department ID. Value is the rest of the thing. Then this is whatever I have done. It is in setup method. Guys, try to look at here. It is a setup method. Why I'm doing this in setup method? Because setup method will execute only once in the life of a mapper. So my cache or my map has to prepare only once. I don't want to prepare map every record or every employee. It should prepare for once for each mapper. That mapper can process one employee ID or 10 employee IDs. I don't mind. It has to prepare only once for each mapper. Now in map method in map method you can go with your logic. So look at here, I'm taking this input, or I'm taking my data, splitting into by comma separated or tab separated, whatever the data. Then I'm looking whether that whatever the file I'm looking into, map dot get of department ID. So here is a different example, guys, but I'm explaining with the department. So I'll pass my department ID and I'll look for whether this is there or not. If it is there, bring everything and club them and emit as output. Bring them and emit as output. So you nothing to do with your reducer, because nothing is there for the reducer, because we are doing in the mapper level. The joining we are doing at the mapper level. So the distributed cache is one of the example for map side join. One of the example for map side join. I hope it makes you clear. If you have any doubt, please ask me. This is how the distributed cache works. And if you want to do one more example, you can do one more example. Here you have one more example. So here I have something called phone book, and I have something called phone numbers and phone books. So I'm also doing the same thing here. If you look at here, I'm also looking I'm also doing the same thing here. Distributed cache, add cache files, and go to your mapper. In the mapper method, in the setup method, get the cache file, prepare your lookup, and so you start looking up into whether it is there or not. Whether it is there or not. But it is wrong, guys. We should not read and prepare in the map file. If you do it in a map file, it is wrong. It will execute so many times. But your object has to prepare only once. So don't do it in a mapper level. Do it in a setup level. In setup level only, you prepare the hash map or tree map or hash set, whatever you feel, whatever the comfortable for your logic, you have to prepare that. Okay. So that has been said about the distributed cache. Any doubts about the distributed cache? Any doubts about the distributed cache? Are you guys clear about the distributed cache? This is very much important, guys. This is very much important thing. Okay, we'll go through it. Okay, so it's very much important. Please go through distributed cache one more time, and the distributed cache document also available in the drive. You no need to run here and there for to get the details. You have something about the distributed cache in Google in our drive. where we are sharing the notes. You please go through it. Please go through it and try to get a understanding of it. If you see here, notes, Mapreduce, notes, you'll be having a detailed notes here. Let me show you where it is. If it is not there outside, it will be there sure in this Mapreduce notes. It will be there here for sure. Okay, you can go down. You can go down. All basic things will be there in these notes. So combiner, partitioner, side. This is called uh, side distribution, data side distribution, side data distribution. Sorry, side data distribution. Your inputs plates, input formats. Come on, in sequence file. Your compressions. Whatever we have discussed about the compressions. This is the compressions. Okay, and this is limitations of the classical. Okay, so why we need a Mapreduce 2? So here it will explain you a little bit about why we need a, why do we need a Mapreduce 2. You can also look at there. And side data distribution. Yeah, side data distribution. Side data distribution is nothing but the side data means joining two data sets. The side, now the department data is the side data for you. Multiple input files, Mapreduce is nothing but side data distribution. Multiple inputs. Instead of giving only one input to your Mapreduce, you are giving multiple inputs and joining for a joining, not for simply processing. Okay, so you can understand here in this document clearly what is a distributed cache. You can look at here. So employee ID, employee name and salary, and you have something called uh, distributed cache. Okay, and also you need, that's what I was trying to thought to show you, a local cache, the cache memory. So it is a 10 GB by default. By default, it's a 10 GB memory. You can keep it 10 GB size of the file. You can keep in a cache. Okay, and this is how we'll keep in a cache. Let me show you. This is the mapper code. Let me show you driver code. This is also map method. Here's everything is clearly mentioned here. Distributed cache dot add cache file, and we'll add the cache there. We'll add the cache there, and we'll start processing it. Okay, so you can have a look one more time with the data and what this data is, what that data is. Look at that, and you can have a look. Okay. Okay, when you want to join two data sets based on some key, you can keep one file into cache memory, and now you can keep other file into. You can look at here. You can also have a what is the add cache file, what it will do, and you can try to understand it. What is the map method? The clear explanation is there here. Okay, coming to input splits and all, you guys very well know about what is input split, recording, reader, and all are you are very much clear. I strongly recommend you guys go through this document. Okay, these are all we discussed very high level and detail as well. Not only high level, we discussed everything, each and everything in a very detailed level. So please go through this document. You will get an idea of how it will work, what it is. Okay, so this is, yeah. And for other concepts like counters you have here, circular buffer you have here. Okay, the flow, what is the Mapreduce flow, how the Mapreduce flow, complete Mapreduce flow. We thought to spend some time on this. We will spend some time on this. Okay, I'll also make you spend end to end from the starting of the your giving your inputs to your mapper till reducer output, what will happen, all the details we'll look at there. Custom output format, custom input format, what is the writables and things is here. You can see a counter separate file, partitions, invert index problem. Okay, mapper 1 versus mapper 2, This is for the setting up your cluster. Secondary sort we will discuss next class. Guys, I would like to prefer keep a class tomorrow morning once. And from first onwards, at any cost, I'm going to start the Hive. So whether it will complete or not, we will take it for some other day. Whatever is completed till 31st, when till tomorrow, we will stop MapReduce, then we will start Hive. We will start Hive. Okay, data intense processing, your this thing, you have so many useful documents here. Secondary sorting, partitioning, multi outputs, file compressions. You can look at here, guys. Joins, map side join, detailed map side join. How will you do a join at the map side? How will you do a join at the map side? The map side join is a little difficult for the. See, now the use case whatever we have seen is one is a bigger file, another one is a small file. Let's assume that both are very big files. Let's assume that both are very big file. How we will do the joining on them? So we will do with the map side join. Very simple. We will process as you know that. So both the data sets, both the data, we'll discuss about it. So I don't want to make you confused in this. Okay. So here the two scenarios are there. One scenario with a small file, one scenario with a bigger file. You can have a look on here. Okay. It is really too good. Maps join sample Java using reference with a bigger file, not the small file, with a bigger file. Okay, that has been said. Yeah. So you guys go through this document. I strongly recommend go through this maps join document as well as the other document what I have shown before. Okay. Thank you guys. Thanks for your time. Have a great day and happy weekend. I mean, so today is not happy weekend, but for tomorrow I want you guys to come and join the class. Please discuss and please let me know. Okay, please don't expect the ping from my side because these days I became little busy. Sorry to say that. You guys discuss and let me know. Then we can finish one more topic. At least joins anyways covered. Only topic is secondary sorting. Secondary sorting is another important topic I would like to bring to explain you guys. So please discuss among you guys and let me know whether we'll have a class tomorrow or not. I recommend we'll have a class tomorrow morning to complete the topic. From Monday onwards, we will start the Hive. We will start the Hive. Yes, that's it.